The circle K has a center of 1 minus 2 and a chord AB where AB is 4 root 3. The point D is 3, 2 is the midpoint of the chord AB, as shown below. Find the radius of K, find the radius of the circle. Now, here's what we know already. We know that this red line here is half of 4 root 3. That would make it 2 root 3. And what we're after is the radius, which is the blue line. We know that this is a right angled triangle because the midpoint of a chord is a line that hits the circle at 2 points. Midpoint of a chord makes a right angle with the center of the circle. So I can use the distance formula, which is this equation here, and I can find the distance of the green line. You see the green line? We're going to find the distance of the green line, okay? And that'll be x1, y1, and you can be x2, y2. We'll put all this into the calculator. We're going to get 1, take away 3 squared. We're going to get y2, which is minus 2, take away y1. Okay. And then when we throw all that into the calculator, we should get a value of 2 root 5 or root 20. Okay, so we know that this green section is now 2 root 5. Now we're after the blue section, which is the radius. We're going to use Pythagoras' theorem. Radius squared equals 2 root 3 squared plus 2 root 5 squared. Radius squared equals, for argument's sake, 12 plus 20. Root 32, I think we're looking at here. So I'm thinking R is root 32. And root 32 is 4 root 2. So the answer for the radius is 4 root 2. Happy days. All right, part B. Show that these two circles touch externally. When circles touch externally, they basically, there's the sum of the two radiuses is the same as the distance between the two centers. Okay, so these two blue lines are the center. This can be R1, this can be R2. And what you're basically saying is that the distance between the two centers, D equals R1 plus R2. Now, there's two systems at play here. The two systems at play. The first system we're going to use is the GF method. So x squared plus y squared plus 2gx plus 2fy plus c equals 0. Now, 2g equals 4, g equals 2. 2g equals 4, g equals 2. 2f equals minus 2. F equals minus 1. C value of minus 95. Okay. So the center of the circle is minus g minus f. Minus g minus f in this case will be minus 2 and 1. Its radius will be g squared plus f squared minus 95. Put all that in the calculator, you're going to get a radius of 10. Okay. Next thing we're going to do is we're going to use the HK method for this. X minus h squared plus y minus k squared equals r squared. R squared is 25. This means that r equals 5. Okay. And then h, instead of h you have 7, so h is 7 and k is 13. So this will be the center of the circle will be 7, and 13. So in a way, this diagram is sort of reversed. So I'm just going to scroll down here. So in a way, what we've done here is that the large one's on this side, the small one's sort of on this side. And now it's not orientated like this, but I'm just giving you a rough idea. This is minus 2, 1. It has a radius of 10. And this is 7, 13. And this has a radius of 5. Okay, so what we're going to do is we're going to say that R1 plus R2 is 15. Now we're going to get the distance between the two centers. So that'll be x1, y1, that'll be x2, y2. So we're going to do the x2 minus, x2 minus x1, so it's going to be 7. Now we're doing this equation here. So we're going to do x2, which is 7, take up plus 2 squared. And then we're going to have 13 minus 1 squared. And we're actually going to get 15. And now that the distance between the two centers is the same as both radiuses added together, means it definitely cuts externally. Now, there are infinite number of circles which touch the circle C externally at the same time S touches C. Find the coordinates of the center of one of those circles apart from S. No bother. All right. So, which one are we looking for? So, just the center is all it wants. Okay. I might use GeoGebra just to explain this, okay? Might be a bit easier. Okay, so using the information from the last question, there are an infinite number of circles which touch circle C externally at the same point that S touches C. Find the coordinates of the center of one of these circles apart from this circle S. So I'm going to show you a diagram here, right? This diagram here is actually the two circles in question, like basically the two of them basically touching each other externally, okay? This is the point 7, 13, radius 5. This is minus 2, 1, radius 10. Now, along this line here, the line joining the two centers together, I can pick any point along this line and I can form a new circle at will. And this new circle will hit at the same spot as the old circle. Doesn't matter what point I pick. I can pick any point on this line and any other circle will hit this circle at the same point. They'll all be external. So I just need to pick a point that's a bit further away just to be safe, because if I go too close, I end up inside, which I don't want. I want to be clearly outside the boundaries. Okay, so what I'm going to do is I'm going to go back to my simple diagram here, right? And I'm going, no bother, you are minus 2, 1. And all the way up here is 7, 13. Okay. And what I'm going to do is I'm going to pick something further along this line. I might just double the distance or something like that. Okay. So minus 2 goes up to 7. That's plus 9 to x. Okay. And then 1 to 13 is plus 12 to y. Just to be safe, I'm just going to double that distance. I'm going to put a circle all the way up here. And this circle, as we rightly discussed, is going to go all the way and it's going to touch it at the exact same point right down here. So I'm just going to be careful not to go inwards, right? So I'm just going to go, no bother, same ratio. Add 7 to 6. 7 plus 6 is 16. 12 plus 13 is 25. 16, 25, no hassle, easy peasy, right? So if I go back to my more complicated diagram, I know you obviously couldn't do this in a test, but I'm just going to get rid of all these markers here. That's a very, very difficult question, to be fair to it. And what did I go for? I went for 16 and 25. So here's 16 and 25 now. 16 and 25 is all the way up here. So I'm going to have to redo my diagram a little bit. Just going to have to drag it down, just scale it up a bit better, drag this in. Now that's my new circle. And look, once I draw this circle, I can expand it out, and guess what? It hits at the exact same point. So that's all good. Cool. All right.